Today we will do another interesting Java program. We are doing Java program, and the name of the program is uh, to check whether it is a Niven number or not. So write a program WAP to input any integer number and check whether it is a Niven number or not. Okay, so let's take an example of an even number. So example 217, 18, 135. Now you see why am I telling this. So first you know what is an even number. If you see here, if you take an example of this 217, see at first you have to extract the digits and then you have to find the sum of the digits. So 2, so here see what is coming. You have to, after extraction of digits, sum of the digits is equal to 2 plus 1 plus 7. What are you getting? 2 plus 1 3 and 3 plus 7 it's 10. Okay, 3 plus 7 it's 10. Now see this sum of the digits. If the sum of the digits divides this number, then it is a even number. But you see here, this sum of the digits is actually not dividing the number. See 10, what is it coming? It is not getting divided, so it is not a even number. But now you take an example of this one. So this is not an even number, but you have to check. I am giving you some examples. I have given you 3 examples from which the first one we found it is not a even number because the sum of the digits is not a factor, means the sum of the number is not divisible by the sum of the digits. So now you see this one 18. After extraction of digits, sum of digits equals to 1 plus 8 equals to 9. Now if you divide 18 by 9, you are getting 2. So your remainder is 0. Therefore 18 mod 9 is equals to your coming 0. And as it is coming like this, so you can say that the sum of the digits of the number is actually the number is actually divisible by the sum of its digits. The number is divisible by the sum of its digits. Okay, so this is a even number, but this is not a even number. Now you see 135. Let's check. Let's extract the digits 1 plus 3 plus 5. After extraction of digits, we will find the sum of the digits. We are getting 9. 1 plus 3 it's 4. 4 plus 5 it's 9. Now let's divide 135 by 9. What is it coming? See, it's completely divisible. So 135 mod 9 equals to 0. So here also the number is divisible by the sum of its digits. So any number in which the number itself is divisible by the sum of its digit is called Niven number. Niven number is also known as Harshad number. Note, it is also known as Harshad number. Okay, so this was our dry run of the program. Just we took the example. Okay, I hope the example is cleared. So now I am clearing this. So we are getting two examples of Niven number. One is 18, another is 135. More we will get if we calculate. Now we will start with the program. Okay, so let's declare the class. Let's initialize and declare the class Niven underscore number. Then we are putting the first curly brace, and then we are declaring the static, which is void in return type, public static, which is void in return type. So public void display, we are declaring the method here. We are declaring the method. That is, we are doing the method call. So public void display, let's input any integer number, int n, let's input it. Next, so we have declared the class. We have also declared the public class, which is of return type void. Now what we will do? Now in order to do the program, we need to first take the number. So see, now let's discuss about the dry run. Let's talk about the dry run. Suppose we took the number 135. So from this number, first we need to extract the digits. First we need to extract the digits, right? So in order to extract the digits, we have to perform a loop, and also we have to input a variable named d, int d, which is of int data type. So I am initializing a variable which is d, and which will help us to find each digit individually. So I am initializing it with 0. Okay, after once we find the digits, now concentrate on the dry run. Once we find the digits, we have to find the sum of the digits. We have to find the sum of the digits. Okay, so in order to store the sum of the digits, so the sum of the digits is 9. In order to store this sum, we need another variable s. Okay, you can name anything, int sum, anything you can name. I am naming it as s, and I will initialize another variable s, in which I will store the sum of the digits. Int s equals to 0. Okay, so this was our total initializing process. Now we will start the main loop. So let's start the loop. For you all know the loop of digit extraction. For int I equals to n, I greater than 0, I divided equals to 10. This is the loop of digit extraction. Okay, this is the loop of digit extraction. For int I equals to n, semicolon, I greater than 0, I less than equals to 10. This is our iteration statement. This is our initializing test condition, and this is the initialization, this is the test condition, and this is the iteration statement. Means how much time the value will keep on changing, increasing. Now what we will find, these loops helps us to find extract the digits. So d will be equals to I mod 10. D will be equals to I mod 10. So now concentrate here. I is what? I is our n. So whatever is the n is the number. N is what? N is 135. Okay. So when we are performing 135 mod 10, what are we getting? Actually, what are we getting? See, 10, 135. So this is what we getting. So once we perform the mod division of 135 by 10, we are getting the remainder, which is the 5. So we got it, remainder. And now if you look it very carefully, from the number 135, the last digit, which is the 5, is calculated by this process. Means we are able to separate the last digit of the number 135 by performing mod division by 10. Okay, see, 135 mod 10 means we are calculating the remainder, and remainder is 5, and 5 is the last digit of the number 135. So in this way we can separate one digit. In like this we have to separate all the digits. Now see, let's not keep the 5 with us and again perform it with 13, because 5 is separated. Now see, 1, 10, 3. Okay, so 13 mod 10, this gives what? 3. It gives 3, and 3 is the second last digit of the number. So in this way we are able to separate another digit of the number. And lastly, what we will do? Lastly, see what is left with us. 1. So 10 mod 1, 10, 1, 0, 0, 1. So see what is getting? We are also getting the first digit. Means 10 mod 1. Sorry, 1 mod 10 equals to 1. So in this way we are able to extract all the digits from the number by performing this process. So this is the most conceptual part of this program. Now, after we have extracted the digits, we have extracted 3, we have extracted 1, we have extracted 5. Now what we will do? We will find the sum of the digits. So the whatever we used here, S, whatever we initialized here, that I will write here. S will be plus equals to, S will be plus equals to D. This means C. S plus equals to D means S equal to S plus D, means the value of S will be changing. The value of S will be changing. So in this, by performing this statement, we can get the sum of the digits. Okay. Next, let's close the bracket. Means let's close the loop. Now what do we have to check? Now we have to check whether the sum of the digits, whether the number is itself divisible by the sum of the digits. Okay, so let's check it. Let's check it. If the number is divisible by the sum of the digits, means n mod s double equal to 0. Let's understand this particular step. See, actually the number is 135. Sum of the digits is 9. So let's perform the division. The division is already performed here. You can see. Sorry, I actually rubbed it. So I'm performing for you once again. So we are getting the remainder 0. So when the number is divisible by its sum of its digits, and we are getting, after performing the mod function, the remainder equal to 0, then only we can say it is a Harshad number or Niven number. So this is our condition what we will apply. If this occurs, if this is correct, if this executes, then it will come inside the brace and print system.out.println. What we will print, let me rub this portion. I am writing it here. Okay, actually we should write, okay, let's write like this only. Niven number. Okay, else system dot out dot println not a Niven number, and thus we close the bracket of else, and the bracket of for is already closed, the bracket of public class and the bracket of class. So this is our program. This is the program what we did using for loop. Now we will do the program using while loop. Okay, now let's do the program using while loop. We will just change this area. Just the loop we have to change. Okay, so in order to do the program in while loop, we have to input it in the beginning. Int, initialize it in the beginning. Int n will be equals to, do like this. Int I will be equals to n. Okay, in order to do the program in while loop, we have to initialize it outside the loop, before the loop. So now we will write while the test condition I greater than, while I greater than 0. Now what we will write, whatever we wrote inside the loop, d equals to I mod 10 s plus equals to d. Okay, and now we will write the iteration statement, means I divided equals to 10. Okay, so this is the code. Please go through the code and tell me if any doubt is there in the comment section. Thank you.